Assalamu alaikum. I am Affan Ahmed Khan, and I have designed this beautiful model by using Solidworks and PTC Studio. Basically, the design was completed by using Solidworks. As you can see, the Solidworks 2020 interface, and basically this is a knee replacement design. You know that many patients has lost their knee due to some accident or age factor. So this is the knee replacement implant in bioengineering or orthopedics implant. So this it consists of mainly three components, but I have designed two components. The upper one is called femoral component, as you can see here, and the lower one is called the plastic spacer, and there is also a third component in many cases, which is called tibial component. So but I have designed only two component and simulate and using as is. You can change color on your own wish, steel, aluminium, or any other material if you want to change. This will give beauty to him. So this is more beautiful, more attractive. So then the assembly of these two designs, there are basically two designs, the upper one and lower one. These are separate design. So the lower one is also made by SolidWorks. You can see here the second design is opening, and this is second design. This is femoral. This is plastic spacer made of PWK plastic. Okay. This on this surface, the femoral component will glide to restore the knee motion. Then the assembly was done in PTC Parametric 3.0, and the file has been imported on Ansys to perform structural analysis. This is Ansys. You can add engineering data from here. The windows is opening. You can click here to add a new material and give name knee bone or femur bone. It's up to you what name you want to do. This say question mark. This means this required certain quality. Go to elastic material, where is linear elastic, and double click on isotropic elasticity. Okay. Add two properties here. Change it to megapascal, because properties are usually in megapascal. Young modulus add 17,000, or you can take it by Google Chrome. What are the properties of biomaterial for femur bone or any other implant? Just I arbitrary at 0.33 pause annotation. Then comes to this window, double click on model is opening. Yes, model will open. It will take few seconds, and then go to geometry. There are two part 2, part okay. Go to part 2 and assign material from here. Material assignment, structure is change it to femur. Whatever material you want to add, you can add by same material. You can also search from here, titanium, plastic, or any other material. So you can search by here. Okay, there are a lot of material: alloy, aluminium alloy, and back hardening or tube aluminium. So you have to add biomaterial for this process. Then go to meshing, static structural, apply fixed support or any other type of support on you have need, and apply force or remote force, whatever you want. Click on this force and this force, this face, apply, give magnitude, arbitrary magnitude. If you want to change direction, you can change by him. This is tensile force. We want compressive, click here. This will make compressive. Go to solution and find stress 1/6 and click on solve. This will solve your model. So based on your computer codes and hard drive, this will take a few seconds or up to few minutes. then it will show how the stresses will generate in orthopedic implant by using these material, femur material. Or okay, I will tell you about the biomaterials in later on another video, but there are mainly three biomaterial used in this field. Okay, this beautiful stress graph. If you want to hide this, go and hide body, then go to this maximum stress or show all bodies. If you want to find maximum minimum stress, you can go here. Where to find maximum minimum stress? This result minimum maximum, can use prop to find this. Okay, clearly shown the maximum stress find here. These all researchers have get maximum stresses here, so our results are verified. Okay, thank you. If you want any help, you can contact me AFFANANED 399 @gmail.com. Thank you.